Welcome friends to this series of learning Google Cloud Platform. In the last lesson we learned what compute engine resources are, what are the different types of images and OS available for compute engine resources. If you haven't watched that video, we are requesting you to watch that video first and then come back to this demo. We are providing the link to that video in description. In this lecture, we will create a new VM instance. However, unlike other available resources, we will go through each and every option and configurations available to create a VM and will explain in detail. Are you excited to have this experienced? I am sure you will be delighted to have this learning. If you have not yet subscribed to this channel, please do it now. This will help you to watch when new videos will be available. Also please hit the notification button so that you can get notified too. So, let's get started. Welcome friends. Please note this is the Google Cloud Platform Web Console. And we are at the homepage of this web console. At the top left corner, you can see the hamburger menu. If you expand that, you can have the full list of different services offered by Google Cloud or GCP. Either you can type VM instance in the search box, or you can click this plus create a VM button on the homepage, or you can navigate to the left panel and go to the compute engine section to create a new VM instance. Make sure you are in the right project on the top. If you select this arrow, you can see which project you are right now working with. Now, in this screen just make sure that you are on the new VM instance creation page. Now it is good to create a VM instance. First, give the name of this instance. You can give any name. Make sure name must start with a lowercase letter followed by up to 62 lowercase letters, numbers, or hyphens, and cannot end with a hyphen. So, my -VM-1 should be a good name. Now let's move to the region section and zone. Make sure you are aware of the region and zones. If you are not, then make sure you have watched the earlier video where we have discussed region and zones. It is very important to know what region and what zone we need to choose to create a VM instance. Ideally, we should create the VM instance closer to the users. Say for example we are having the American clients at the central region and we create the VM instance at US Central 1, which is nothing but the Iowa region. Now we need to choose the machine configuration. If you are not familiar with these machine configurations and the different types of machines, then I would again recommend you to check our previous video so that your understanding will be better. For a general purpose low-cost day-to-day computing, we can choose an E2 instance. Now, notice this E2 instance can have minimum 0.25 to maximum 32V CPU and can have 1 GB to 128 GB of memory. This we will further configure in the machine type section below. Either we can choose preset configuration, or we can use a custom one. This drop-down menu will provide a list of preset machines having specified CPU and memory. We can choose CPU and memory that are predefined from this list. We can go to these custom tab where we can specify our custom CPU and memory. We have slides for the cores and memories. We can slide this and we can adjust core and memory accordingly. Now note here, if you change core, memory will be automatically changed. Now carefully look. There is a checkbox that indicates shared core. If you turn this checkbox on, then you cannot change the core's slide anymore. And you cannot go beyond 8 GB memory. You are sticked with one vCPU. Now, you need to know what exactly this shared core is. GCP shared core machine types share a physical core between virtual CPUs for multitasking. The E2 and N1 series contain shared core machine types. These machine types timeshare a physical core, which can be a cost-effective method for running small, non-resource intensive apps. This can be a cost-effective way to run small, non-resource intensive apps. Shared core machine types can provide bursts of physical CPU for short periods of time when needed. For example, the E2 series offers two vCPUs for short periods of bursting. Shared core machine types are available for applications with very low resource requirements. Shared core machine types offer bursting capabilities that allow instances to use additional physical CPU for short periods of time. Bursting happens automatically when your VM requires more physical CPU than originally allocated. During these spikes, your VM will opportunistically take advantage of available physical CPU in bursts. Note that bursts are not permanent and are only possible periodically. The exact burst time is determined by a token bucket, meaning utilizing the CPU less than 100% will result in longer bursts. Bursting doesn't incur any additional charges. Now, let's expand this advanced configuration section. You cannot change the CPU platform as it is set as automatic, and your CPU platform will be automatically selected based on your machine type. Next is vCPU to core ratio. If you select 2 vCPU per core, you are actually having 4 vCPUs altogether. You can select a custom multithreading ratio. This performance and cost implication will be impacted accordingly. Next is visible core count. If you keep shared core checked, you cannot change anything here because your visibility of core does not make any sense. However, once you uncheck this, you can select the visible core count. If you select 2 cores, that means if you select 2 cores, you actually selecting twice vCPU and you will be charged for 6 vCPU. Next is coming availability policy. I would recommend to go through our earlier video if you have not watched yet. There we discussed what is Spot VM is and how it can give you the benefit of cost reduction and to run temporary batch workload. Note, if you select Spot VM, your cost is getting significantly coming down. Wait for some time if you are not getting the cost immediately. See how it is getting down if we choose Spot VM. Well, I am going to change it to standard VM provisioning. Again, notice how the cost is going to change if we select standard VM. Next, let's go down further by scrolling the page down. We can set a time to limit for the VM to stop or terminate. You can specify time limit by hours or you can specify date. Once you set the date or hours, your VM will be either stopped or terminated based on the selection you make in this section on VM termination. Let's keep this as delete so that this VM will be terminated after certain period of time. Next is coming on host maintenance. When compute engine performs periodic infrastructure maintenance, it can migrate your VM instances to other hardware without downtime. Terminating a VM instance on host maintenance is not a recommended selection anyway, unless your business needs that. Let's select the Migrate VM instance. Compute engine can automatically restart VM instances if they are terminated for non-user-initiated reasons like maintenance events, hardware failure, software failure, and so on. And it is highly recommended to keep this as on and rather you make your application resilient with fault tolerance. Next, enable to use screen capturing and recording tools. However, we are not interested here to enable it. So, let's have it unchecked. Next very important thing is coming, which is confidential VM service. This service adds protection to your data in use by keeping memory of this VM encrypted with keys that Google doesn't have access to. You can keep disk encrypted to have your data in rest protected. But what about if the data is in memory during processing? Here is the way you can keep your in-memory data protected by making the VM as confidential VM. Note, you need to have N2 series machines to have this feature. However, we are here keeping this disabled and will go with E2 series. You can deploy a container to this VM instance by using a container-optimized OS image. If you click Deploy Container, you can have different options to provide container image registry location for you. Next very important part is coming for selecting the right boot disk. We are again recommending to watch our previous video lecture where we discussed different public OS image supported by GCP. You can have the link of this earlier session in the description. Anyway, you can click Change button to change the OS image type. Under Public Images, you can select different operating systems. You can choose Debian, Fedora, a different Linux OS or Windows Server as well. Also, if you have created any custom image earlier, you can go to the Custom Images tab and can select that image here. In the next lecture, we will show how to create a custom image and build a VM instance from that image. Similarly, if you have snapshots or other boot disks with you, you can create a VM from that too. We will see all these things in upcoming videos. For now, let's go to the Public Image tab and select Debian image. Also note, we can change boot disk type. We can either select standard disk, which is the best use case for cost-sensitive, throughput-optimized non-boot data drives. Also we have SSD for performance-sensitive, business-critical applications. We have balanced for general-purpose enterprise applications. We have Extreme 1 for high-end database workload like SAP HANA. If you click Compare Disk Types, you can get details of these use cases. One important part to notice here. If you change the size, you can see IOPS are getting changed. More you add size, the more IOPS you will get. From here you can conclude, if you are having any performance issues like slowness, you can simply increase the size to get more IOPS. Let's go back and leave the boot disk size as default 1 and click Select. Next, Identity and API Access. Here you need to provide the service account on which you will have to give access to other services. We will go through that when we will discuss IAM. Next, select the type and level of API access to grant the VM. By default, it will have read-only access to storage and service management, write access to cloud logging and monitoring, read-write access to service control. However, you can give full access to all Google API or select each API individually. It is not recommended to go by this. Rather, this should be granted through proper IAM or service account, which we will discuss later. We can allow or disallow certain protocols like HTTP or HTTPS traffic. However, it is not recommended to allow ports here. Next, you can install OPS agent for monitoring and logging. This will help to capture additional monitoring information. Now let's move to the advanced option. Expand the networking tab. In subsequent lectures, we will see how we can use tags to allow traffic on different ports through the network. We can set a custom host name for this instance or leave it default. We can keep a hostname like my VM. We can also set IP forwarding. Forwarding allows the instance to help route packets. We are not going to another networking section and will revisit here when we will discuss networking. Other than boot disks, we can add other disks. Please note, we need to manually mount each of them, and they will not be mounted automatically when the VM is started up for the first time. Under the Security section, we can enable Secure Boot. Secure Boot helps protect your VM instances against boot-level and kernel-level malware and rootkits. We can turn on Virtual Trusted Platform module, which validates your guest VM pre-boot and boot integrity and offers key generation and protection. Integrity monitoring lets you monitor and verify the runtime boot integrity of your shielded VM instances using cloud log reports. This requires VTPN to be enabled. Let's skip the next part and we'll revisit when we will discuss SSH key login. Let's go to Manage Access. We can provide a description of the VM here to specify purpose. We can keep deletion protection. When deletion protection is enabled, an instance cannot be deleted unless altered. If you want to take a sustained discount, you can use reservation. Another important thing is automation. You can choose to specify a startup script that will run when your instance boots up or restarts. Startup scripts can be used to install software and updates, and to ensure that services are running within the virtual machine. Startup script will be run by root user. Next, you can set custom metadata for an instance or project outside of the server-defined metadata. This is useful for passing in arbitrary values to your project or instance that can be queried by your code on the instance. Next is data encryption. You can either choose a Google managed encryption key or you can provide your own key if you have already created it. Next section is for sole tenancy. If you want to run your VM at a dedicated hardware, you can go for sole tenancy. Note, not all types of VMs are eligible for this one. Now let's click the Create button to create our first VM. Our first VM is now created successfully. Thank you friends for watching this video. We from the Learning Light team congratulate you to complete this learning. In the next lecture, how to log in to this instance and play on it. Wish you all the best and good luck. Before leaving here, please do not forget to like this video and subscribe to this channel. We worked a lot to present you with such a thing. So, please encourage us by putting your comments in the comment section. If you have any doubt, please leave your concerns and we will reply with our best efforts. Have a nice day and see you in the next lecture.